Hello students, today we will do the problems related to Thevenin's theorem. So in this type of problem, ask maybe in your competitive examination or public sector exam. So there is a bridge is there. So how to apply Thevenin's theorem in this problem? Find the current through the galvanometer using Thevenin's theorem. This is a galvanometer and this is a balanced bridge. If the bridge is either you have to look whether the bridge is balanced or not. That means the product of the opposite arms must be equal. This into this. If this into this equal to this into this, then we can say that the bridge is balanced. But here the bridge is not balanced. So we have to find out how much current flows through the galvanometer. Here the galvanometer resistance is 11.1 ohm. So by Thevenin's theorem, how to find out how much current flows through this galvanometer using Thevenin's theorem. First of all, what we will do in step 1? In step 1, generally what we will do? First of all, to find out the Thevenin's voltage or open circuit voltage. How to find Thevenin's voltage or open circuit voltage? Simply you disconnect the load resistance, then find out the open circuit voltage or Thevenin's voltage. In step 1, that is your disconnect the load resistance. Disconnect the load resistance. Disconnect the load resistance. Here the galvanometer is your what? That is your load resistance. You can say the 11.1 ohm. Simply we have to disconnect it. If you disconnect it, the figure, we have to disconnect it. Then find out this is your what is your Thevenin's voltage. That is your, we have to calculate the Thevenin's voltage. If you observe here, this is a bridge. There is the current flow through this one, and this is the division, the current division here. If the total current is your I, and let this current is nothing but I1, and let the current this is nothing but I2. So how to find the VTH? Using Thevenin's theorem, the resistance, how much current flow through the load resistance, first of all disconnect it and find out the open circuit voltage or Thevenin's voltage. So I have already disconnected the load resistance and we are going to calculate the Thevenin's voltage here. First of all, if you look here, the total current I, it is divided I1 and I2, and this is nothing but a series, and this is nothing but a series. The voltage across this is nothing but what? Not 24 volt. First of all, let us calculate potential at this point and potential at this point. The potential at this point is your VA, and potential at this point is nothing but your VB. So VA is how much you will calculate. So simply this is in what? 20 and 250, and the current is nothing but what? The voltage in the VA. How to calculate VA? The I1, the value of I1 is how much here? The I1 equal to, that is your total voltage 24 divided by, that is your 250 plus 20, that is your what? 270 ampere. I1 equal to this one. Then, and this is nothing but your I1. This and this is your series. We are going to calculate this potential, that is your VA. So VA, potential at point A is nothing but VA. VA is how much? That is your 24 volt minus, that is your what? 20 into I1. 20 into I1. That is nothing but VA. So if there are two resistance, voltage across this plus voltage across this is nothing but 24 volt. So we are going to calculate potential at this, means that is nothing but VA. That is your total voltage 24. That is your, at this point, this point is nothing but what? VA equal to 24 minus 20 into I1. This with respect to this one. So that is nothing but 24 minus 20 into I1 is nothing but 24 divided by, that is your 270. The value will be how much? That is your 24 minus, that is your 20 I1 using calculator, that is your 24 divided by 270 equal to this one into 20, the value is like this. So 24 minus this one minus 24, the value comes this, that is nothing but, that is, it is around 22.22. 22.22. VA is your, this is minus, this is nothing but what? VA equal to 22.22 volt. This is your VA. Then we will calculate, that is your what? We will calculate VB. VA equal to this one. Similarly, how to calculate VB? Means what? VB is how much? VB, potential at B, that is your VB. Similarly, the total voltage is your 24 minus this voltage, that is your VB. So that is your 24 minus current, that is your I2 into 40, minus I2 into 40. The value is how much? That is your 24 volt, minus the value of I2 is how much? That is your 24 divided by 475 plus 40. I2 value is your, I2 is nothing but, that is your 24 divided by this, and this is series 475 plus 40. I2 is your 24 divided by 475 plus, that is your 40. This is your I2 into 40, and the value is how much here? So using calculator, that is your, this is your 24 minus, that is your 40, this is your 40, that is your 40 into 24 divided by, that is your 4, that is your, first of all, 24 into 40 divided by, that is your 5, 1, that is your 515. Okay, so that is your what? 24 into 40 equal to this one divided by 515. The value will be your 1.86. So this is nothing but 24 minus 1.864 volt, and the value will be how much? That is your, this is your minus, that is your what? Plus, this will be plus 24 minus 1.1 point, that is your 24 minus, it is around 1.864, it is around 22.136 volt. This is nothing but VB. This is your potential at B, that is your VB. Okay, so here VA equal to, potential at this point A equal to 22.22 volt, and potential at B equal to 22.136 volt. Then find out VTH. VTH is nothing but Thevenin's voltage. VTH equal to VA minus VB, potential at this minus potential at this, and this is nothing but open circuit voltage or Thevenin's voltage. So VA value is how much here? VA is your 22.22 volt minus 22.136 volt. The value is how much here? That is your, using calculator, that is your, that is your what? 22.22 minus 22.136. the value is your 0.084 volt, 0.084 volt. This is nothing but VTH, Thevenin's voltage or open circuit voltage. Here VTH or V open circuit voltage, VTH equal to 0.084 volt. Then step 2, and we are going to calculate Thevenin's resistance, that is your RTH. How to calculate RTH? In step 2, to find RTH, Thevenin's resistance, that is your RTH. To find RTH, what we will do? This voltage will be short circuited here. If this voltage is short circuited here, that is nothing but what? If you will draw the circuit, that is your what? To find RTH, the voltage source should be short circuited and current source should be open circuited. To find RTH in step 2, to find RTH, here that is your 20, this is your 20, and this will be what? And this is nothing but 250 here, this is your 250, and similarly this is your 40, and another one is your what? That is your 475, that is your 475. This is your A and this is your B, this is your 475. Okay, if you thought this is your 24 volt, voltage source short circuited, this 21 250 ohm, this is nothing but your 20 and parallel with 250, and here 40 parallel with 475. Okay, so RTH equal to Thevenin's resistance, RTH equal to this 20 ohm resistance will parallel to 250 ohm. This 20, this is your parallel to 250, and plus 40 parallel to 475. What will be your equivalent resistance? If the two resistance are parallel, the equivalent resistance is nothing but product of the resistance by sum of the resistance. And the value is how much here? So 20 into 250 divided by 250 plus 20, that is your 270, plus 40 into 475 divided by 40 plus 475. Okay, so the value becomes what? That is your okay. So the value will be how much here? Using calculator, that is your 250 into 20, 250 into 20 equal to your what? 5000. 5000 divided by 270. The value will be your, this value is your 18.518 plus, and here that is your 40 into 475, 40 into 475, the value will be your 19,000 divided by, that is your that it becomes 515, that is your 515. The value is your what? 36.89. 36.89. If we add this one, it will be how much? This plus, that is your 18.518. The value will be your how much? 51.411 ohm. This is your RTH. This is your RTH. So already we got VTH, and this is your RTH. This is your RTH value is your 51.411 ohm. Then step 3, what we'll do? In step 3, we have to draw the Thevenin's equivalent circuit. That is your VTH series with RTH, and again we connected the load resistance here. Here the load resistance, that is your galvanometer having internal resistance, that is your 11.11. So in step 3, first rerun the Thevenin's equivalent circuit. In Thevenin's equivalent circuit, that is your VTH. Here this is your VTH. The VTH value is your how much? 0.084 volt, 0.084 volt. RTH, the RTH value is your how much? RTH we got, that is your 51.411. 51.11. Then connected the load resistance here, that is your RL value. The galvanometer internal resistance RL given, that is your 11.1 ohm. Then find out, this is your A and this is your B, and find out the current flow to the galvanometer. Here that is your IL. What is the current flowing through the galvanometer? Let the current is your IL. How to find out the IL? The IL value is your what? That is your IL equal to, find through current flow through the galvanometer equal to, that is your VTH divided by RTH plus RL. VTH divided by RTH plus RL. The value becomes what? VTH equal to 0.084 divided by RTH is your 51.411 plus 11.1. It will be around how much? By using calculator, that is your what? 0.084 divided by, that is your what? It is around 51.411 plus 11.1, and it is nothing but what? That is your, this is your 0.084 divided by, that is your this is nothing but 1, that is your 4 plus 1, 5 point, that is your, is nothing but 6, 3, 1, 1, 2, 5, 1, 6. That is your, it is around, that is your 1, 1, 2 and 5, 1, 6, 62 point. But this is your 0.084. If you add this and this is 62.511. That is 0.084 divided by, that is your 62 point, that is your 511, and the value becomes what? That is your 0.001344. And here the value will be the IL equal to, current through the galvanometer equal to 0.0013444 ampere. If you put this one, I can say that this is your microampere. Micro, this is nothing but, that is your 1.344 microampere. This is nothing but the current flow through the galvanometer. It is very less. So if this type of bridge circuit is given, how to find out the current flow through the galvanometer? And there is a galvanometer here between A and B, and galvanometer having internal resistance was 11.11. The question asked how to find out the current flow through the galvanometer. First of all, in Thevenin's theorem, again I am going to discuss. First, step 1, disconnect the load resistance, then find out the VTH or open circuit voltage. In step 1, what we did first in step 1, how to calculate VTH? This is simply the current can be divided into these two branches. One is I1, another is I2, and we have to find out the potential at this point A. This is 24 volt. This is nothing but 24 volt. Minus, if you minus this, you will get VA. So VA is 24 minus 20 into I1. I1 value is how much? 24 divided by 250 plus 20. Similarly, I2. How to find out I2? Same thing, 24 divided by 40 plus 475. That is your I2. So then find out VB, potential at B. That is your 24 total voltage minus this voltage. That is your 40 into I2. So you can calculate VB. Then VA minus VB is nothing but VTH. There VTH equal to 0.084. Then we are going to calculate, and that is your Thevenin's resistance. How to calculate Thevenin's resistance? To find the Thevenin's resistance, the voltage source should be short circuited here. So I have short circuited this 24 volt. If I will short it, this is a 24 volt, 20 ohm parallel to, the figure is like this. 20 can be parallel with what? This is one path and this is another path. 20 parallel to 50. Again 40 parallel what? 475. So that is your what? This is nothing but, this is your 20 and this is your what? 250. Again this is nothing but 40. Again this is nothing but what? That is your, this is your 20, this is your 250 and this is your 40 and this is nothing but 475. This is your A and this is your B. So this 20 parallel 250 and 40 parallel 475. So if the two resistance are parallel, equivalent resistance is nothing but product of the resistance by sum of the resistance. So this parallel this plus this parallel this, your equivalent resistance will be 51.411. Then you can rerun the circuit by last step, draw the Thevenin's equivalent circuit. In Thevenin's equivalent circuit, this is your VTH, this is your RTS and this is your RL. Finally, the disconnected resistance or internal resistance of the galvanometer, finally you can reconnect it, then find out the current flow through the galvanometer or current through the load resistance RL. The current through the RL is how much? Total voltage VTH by this plus this. So we got IL equal to 0.001344 ampere and the value becomes what? That is your 1.344 microampere. So thank you. In next class again we will discuss more and more number of problems, Thevenin's theorem, Norton's theorem and maximum power theorem, reciprocity theorem and also superposition theorem. So we will do more and more number of problems and it will be very much helpful for you. So if there a problem is given, so you can solve by using any type of theorem which is easy for you. Okay, thank you. Next we will see again. Thank you.